What we have here is the Rockwell Collins MP1, Collins MP1. This is a mobile power supply to supply the radio KWM1 and KWM2A or 2 with 12 volt battery voltage from your vehicle. The unit was developed and sold in the early 60s, and I think it was sold all the way till the mid 70s. And what it is a chopper power supply. It has these germanium power transistors made by Honeywell, and they here you see one that's removed. An old power transistor from Honeywell. It is the DA3F3, and the problem is that these are very hard to find nowadays. They're pretty impressive. They're made out of solid copper, and they're stud mount. That's another problem that you will have if you have to ever replace these things, and you will have to drill holes. They're basically here mounted in this stud, in this screw, and there is two of them obviously in push-pull. Basically forms a power oscillator. The chopped voltage from the battery is then converted upwards with a high frequency transformer, and then we have rectifiers and buffer capacitors. These 6 big capacitors are for the 800 volt output, that is for the power amplifier of the KWM2. Is supplied with 800 volt. Here we have the 2 capacitors, electrolytic capacitors for the 260 volt output, that is for the receiver and the exciter, the KWM2. And this here is the negative bias circuit that supplies the grid bias for the PA, and you can adjust that here with this potentiometer to the right current, the right idle current. A couple of components that you see here. You see a couple of chokes. You see there a big ass resistor that's used to bias the transistors in class A for startup. Once the unit has started up, it switches to class D, but for class A these resistors are necessary to make sure that everything starts properly. And it is a 13.8 volt bypass capacitor. So this was sold, like I said, in the 60s and 70s. And nowadays they're hard to find in working condition, and the reason is because all these, this actually is not too bad. I've seen much worse than that, but these capacitors start to go bad, and then the stuff that comes from this heat shrink sleeving or whatever it is will then also corrode the board. That has not happened with this one yet, but most of these units that you will find nowadays have this this whole board in pretty bad shape. And the other problem is, of course, that if these transistors ever blow, good luck replacing them, because if you want to get other germanium power transistors, then you will have to drill holes here, because the stud mounted one, you cannot find that anymore. And if you replace it with silicon transistors, they have a much higher on voltage, and then the efficiency goes down quite a lot. So repairing this is difficult, and that's why we came up with a solution for that. So here we have another MP1, Collins MP1 mobile power supply, and as you can see, we basically developed a new board for this unit. So the components underneath the board are unchanged. We use the same transformer and everything, but we developed a whole new board for this, and we actually sell this on our website, radio.picorf.com. if you want to restore your own MP1 and actually make it better than new. This has a couple of changes, modifications if you want, that improve the efficiency quite a lot. The biggest one is obviously that the unit has MOSFETs, one here and one here. They're on the PCB. You're probably thinking, why don't they have a heatsink? Well, these things have such an incredibly low on resistance that even during transmitting they don't develop a lot of heat, and they don't have to be heat sinked. I think during receive they develop something like 0.3 watts in heat, and when you transmit it's less than a watt, so they don't really need a heat sink. And that's a huge advantage when you want to put this in your unit, because you know, changing these original resistors is a huge pain in the butt. As you can see, there's just a hole there now, unused, for what we did there. There is no more resistor, transistor used. The other thing that's gone is this whole resistor contraption and whatever stuff is there, this bypass capacitor, because these MOSFETs that we are using are driven by a microprocessor. They're not driven by the transformer anymore. It's a self-running oscillator. These MOSFETs are driven with a circuit with a microprocessor that drives these MOSFETs, and it does that at the optimal frequency that we have found of 1600 Hertz. The original MP1 runs up at around 900. It depends on the load. If it's free running, it's about 950. If it's loaded, it's 800 Hertz. And this here is driven by the microprocessor with a constant frequency of 1600 Hertz regarding the load. Why did we pick 1600? Well, it turns out that's the point where the transformer that's used is most efficient. So that gives us the degree of freedom to use a higher frequency. So that's a big advantage. The other thing that we do is we use the microprocessor for a inrush regime. In other words, if you turn on the MP1, usually what would happen is then all the filaments of the KWM2, the tubes, are starting to be powered, and these tubes are basically PTC. So when you turn on the unit in the original condition, the current is very high because all the tubes have to be started with a high current, and at the same time this power supply starts to run, and as a result your current that you draw from the 13.56 megahertz, 13.8 volts DC is very high, and if you use a standalone power supply it might collapse or go into fallback. And also if you use a car battery, it's quite a sudden power drain. So what we have done here, we wait 2 seconds turning on the whole circuit. That is enough to get the tube started and the current to dramatically drop off. Then we start the MOSFETs with a slow ramp up in duty cycle. The drive signal is ramped up in duty cycle, so the voltage slowly goes up and doesn't give a sudden bang on your KWM2A. So that will spare the capacitors much better that actually are in that unit. So that is a big advantage here. An inrush current protection. Of course, we can still set the PA bias. That hasn't changed. These capacitors are the 3 capacitors for the 800 volts. That has, in concept, not changed. In the original design, there is 2 diodes in series in the bridge rectifier. We have used 2 kilovolt diodes here for the 800 volt, so it was sufficient to use a single diode. And here is the diodes for the 240 volt receiver power supply and exciter power supply. So the result is a power supply that has a much higher efficiency. I have done an efficiency measurement with the original MP1. I get 69 when I load the 250 volts with about 100 watts. I get a 69% efficiency. If I do the same with this power supply, the modified power supply, we get 82% efficiency. So the current that you draw from your car battery or your power supply is significantly lower. And the other nice thing is there is much less heat developed. It works so well actually, and I'll show you that later, that you could use this power supply as your permanent power supply for your KWM2. You know, usually it would be the 516F2 power supply, the AC power supply, which are hard to find and heavy. This is much smaller and much more compact, and you could just use that to run the KWM2 from your 13.8 volts. And the current that is drawn during receive is, I think, is about 6 or 7 amps. I'll have to hook it up and show that to you. And when you start transmitting, it's about 23 amps. So when you have a power supply like I do, and I'll show you that later, like the Alinco, that will handle it perfectly. And in that way you can use this as your permanent power supply for your KWM2A. So if you what we do is we basically sell this board. We will put online an instruction video on how to hook that up. It's actually fairly simple. There is these terminals here that are at the same position as the original board, so that you have basically the same connections for your wiring, and with clear explanation. When we put these in a location such that you don't have to do all kind of difficult escapades to use the existing thick wires for this for hooking up these MOSFETs, and the same is done here. So you will have to solder. You have to solder the wires here too, which, like I said, they're laid out such that the existing wiring can easily reach that. Same is true for the potentiometer that you will have to reuse. You can easily desolder that from the existing power supply, and then you can put it in here. So this you will have to reuse, the same potentiometer as the old unit. Then you can just lift the whole board out. I actually have the old board here. I once already fixed that with new radial capacitors, but they're very expensive. So this board then comes out, and then you get this new board from us that you can easily solder in with the instruction video that we will make available. So if you have an MP1 laying around and the capacitors are all busted up and everything is in poor shape, then you can make the unit better than new by buying this board from us and installing it. Here a quick overview of the original schematic diagram. As you can see, these are the two DA3F3 germanium power transistors. This is the rectifier for the 800 volt, this is the rectifier for the 260 volt. And here you see the rectifying the circuit for the PA bias. That's with the single diode rectifier. And here is the whole circuit. As you can see, it is a self-oscillating circuit. It uses this part of the transformer as a feedback to these germanium transistors, and then this resistor network is what I showed you earlier, is used to keep the whole circuit in class A during power up, so that it can start to oscillate. Once it oscillates, it's basically a multi-vibrator, and the only downside is, well, there is multiple, but one is that you need 1/10 of the produced current to keep these transistors going, because the HFE, the current gain for these transistors, is only 10. So 1/10 of the current is used to drive these things in saturation to keep the class D operation and therefore the high efficiency possible. So that is a downside. And that also means, because this is a self-oscillating circuit, that when you have different loads, the frequency also will change of the whole circuit. Like I said, from 800 to about 950 Hertz. The other downside is that the resistor network here is basically across the 13.6 volts, and it dissipates quite a lot of heat, and that of course lowers the efficiency as well. Now, if we go to the new circuit, on this side things are pretty much the same. The only thing is that we put an extra bleeder in here, bleeder resistor. Collins did not put that in the original 250 volt branch. I don't know why they didn't do that, but we put a bleeder there that at least the voltage will bleed off when you turn the unit off and you don't get shocked. This is the new circuit. We got these two power MOSFETs. These are the two drivers. This is the microprocessor. This is basically to supply 5 volts to the microprocessor. And as you see, there is no resistor network anymore. This network that's here is gone. And the output of the transformer, the feedback output, is also not used anymore. So the 10% current loss you won't have with this circuit. And that basically guarantees a much higher efficiency. That plus the fact that these units have an extremely low on resistance. We're talking milliohms here, which makes sure that the losses, the power losses, are kept to a minimum. And the other thing that we did is it is still possible to use this for both power, for both negative and positive ground. The only difference is that the jumpers will now have to be in a different position for negative ground. They have to be in this position for negative ground for the new version, and in the old version that was like that. You can also see that here. I'm talking about these jumpers here. So that's the position for negative ground in the original MP1. Now that we have this modification, we have for negative ground the jumpers in this position. The reason for that is that we used N-channel MOSFETs here, not P-channel, because N-channel MOSFETs have a much lower on resistance for the same price. P-channel MOSFETs are not as good in that respect, so that's why we reverse that. But like I said, the jumpers allow you to do that. You just have to remember that once you put in a new board, you have to put the jumpers in that position for negative ground operation, and not like it is here. You don't have to mess with the diode. Remember, that's what the instructions say. If you want to go to positive ground, you have to change the diode. Well, you don't have to do that when you do the modification with this new board. So that is another thing. The good thing about this modification is the way we did this is if you ever wanted to go back to the original condition again, you can do that. You know, there is no holes drilled. All the components can be mounted back. You can put the board back, the original board. If you really wanted to do that, and you say, hey, I don't want to, you know, mess up an original piece of Collins equipment and I want to go back to the old situation, you can do that. There is not much need to do it because, like I said, this works so much more efficient and it looks very professional. But if you don't like the fact that there is a modification done, you can bring the whole unit back in the original Collins condition because, like I said, there is no holes drilled when we do this modification. We have the MP1 now hooked up to an actual Collins radio, Collins KWM2, and we'll check what kind of power levels we get. Now, I do not have an antenna connected to this unit, so I cannot let you hear the receiver other than noise, but for the transmitter we can check the power. So we're going to turn it on. Here you can see how that develops in terms of current. This is the, did you see it kick in for the second? That is the actual 2-second delay. So when I turn it on, first the filaments start to draw current, and then the power comes up, the play voltage. Now we're drawing about a 9.5 amp, but you got to remember about 5 amps of that 4 to 5 amps is filament current. The rest is the current consumption for the inverter. And like I said earlier, the receiver doesn't consume much more than 25-30 watts. So 3 to 4 amps is what you would see in receive mode, which is considerably less than the incandescent light bulbs that I used as a load earlier, as you might remember. Well, let's see what we get in terms of RF power. So we'll turn the unit. I already pre-tuned it, so we turn it into, as you see, we're getting about 120 watts from this radio through the MP1, and the MP1 is drawing about 24 amps with an output power of 120 watts, so that's definitely not bad. Yeah, it works very nice. I will show you as a next step what here to see the receiver really works. If I turn on this crappy light, the receiver does work just fine, but like I said, I do not have an antenna right now because of the hurricane we have had here, and I still didn't have a chance to fix that. Anyway, but this is the MP1 actually hooked up to the KWM2A. I'll take off the cover and show you the bias adjustment, and also how it's actually hooked up using the original Collins cable. Okay, we'll take off the cover. You see this is a round emblem one, and here you see our board, the RVB-1P1. So it is really the upgraded units, not the old one. And here you see how this is hooked up. Now, like I said, you need to look at the Collins manuals if you want to do this absolutely right. This white black wire is the 800 volt. This white yellow one is the 13.8 for the filaments. This white gray wire is the on-off cable. That is basically powered through this switch here, like I explained earlier. This white red wire is the 260 volts, and this white, what is it, gray? White brown, I think it is the minus 65. And when you make this cable, if you use the original Collins cable, there is 3 wires that you have to tie together and then tie to ground. It's a green one, an orange one, and the third one I can't see. But like I said, you got to check the manual. Got to tie those together for 12 volt operation for the filaments. And there is 2 wires that you end up not using. One is purple, one is blue. Those are wires that you need for 24 volt operation for the filaments and 6 volts. So if you hook it up like that, you know I've done the right job. But like I said, this is only if you have the original Collins cable. Otherwise you would have to make your own, and then of course you can use whatever you want as long as you hook it up properly. So let's now do a quick demonstration of how you set the bias potentiometer. That's really simple. Okay, we got a KWM2A warming up here. We got that running. Yeah, it's working. And we have the power supply running. We're drawing current. This is voltage, this is current. And here is a potentiometer. So what we do is we turn the unit into transmit mode, but without any audio going in. So that's the idle current for the PA that we're going to see here in plate current. Put this in plate mode, then we're gonna set it to transmit, and that's all you have to do. You have to draw about 25-30. If I set this here, you can see how that changes. So set it about 25 milliamps. And that should correspond to about minus 65. So that's all you have to do. And then you turn it back into receive mode. And you're good. And then you have set this potentiometer in the proper position for the right bias current. And that will give you the best modulation in single sideband. But again, make sure when it runs you don't touch anything, because there is very high voltages here. So once you're done, all you do is turn it off. that will turn off the MP1, and then you turn off your power supply, and then you wait for a while to have these capacitors bleed off. Well, that was the demonstration of the modified, retrofitted, overhauled, whatever you want to call it, upgraded MP1. It's better than it ever was before. Really professional looking job. Arthur Collins would be very proud of us that we have restored his MP1 power supply to better than it was before. Thanks to modern electronics and microprocessors and you name it. Thank you for watching this video.